All right, so here we're talking about a new concept called reference angles, and essentially what a reference angle means is that we can take the values of any trig function of angles that are greater than 90. Those angles that are greater than 90 can be found by using corresponding acute angles called reference angles. And if theta is in an angle in standard position, then its reference angle, which we're going to call theta prime, is formed by the terminal side of theta and the x-axis. So I want to find the reference angle theta prime for each given regular theta. I'm going to do A in blue, B in green. Notice that A is in degrees, theta is in, or B is in radians. Let's start off by drawing a sketch. Okay, and each angle theta is in standard position. Let's do part A first. It's in degrees. So here's 0 degrees, here's 90 degrees, 180, 270. So 320 is going to be somewhere in here. It's just a sketch. So here's my standard position, and I'm spinning around. So this is 320 degrees. I want to know what angle does that correspond with. What's its reference angle? So again, we're going to use the corresponding acute angles. So we're going to do that with the terminal side of theta and the x-axis. All right, well the terminal side of theta for this problem is right here. And here's the x-axis. So that's the angle measure theta prime. Okay? But we want our theta prime to be positive. So you might notice that there's symmetry. So really, theta prime is going to be right here, okay? Because there's a symmetry going on. And to figure out what theta prime is I know to complete my circle is 360 degrees. All right, so what I'm going to do is say 360 minus 320, which is 40 degrees. So again, my theta prime for part A is going to be 40 degrees. So that means if I found cosine of 320 and cosine of 40, those will be identical because I have symmetry going on. These two flip-flop and would, imagine you're folding a taco on top of each other. These two angles would sit on top of each other if I folded this taco shell in half. However, the signs would be exact opposites. We're going positive y direction, so that's going to be a positive y movement. We're going negative y because we're going down. So keep that in mind to check. Now let's do part B in green. We're in radians, okay? So first off, to figure out radians, we're going to have to cut our circle into pieces. So whatever our denominator is, the bottom side, that's what we're going to cut our circle into. So I'm going to cut my circle into sixes. And I'm actually going to draw a new sketch, just so I have plenty of room to work with. So this is for part B. And also it's negative radians, so I'm going counterclockwise. So I know that right here I need to divide 1/2 of my circle up into 6 slices. So I have 1, 2, 3, 4, 5, 6. Okay, and I want negative 5, 6. So I'm going counterclockwise, and negative 5, 6 is right here. So negative 5 pi over 6. So if I rotate counterclockwise. Now what I want to do is to figure out what is the reference angle. And again, what I do is I take my terminal side of the angle. My angle always starts off in standard position. So here I am, and I rotate it around to the terminal side of my angle. What I want to do now is to find theta prime, which is going to be this right here. All right. So theta prime is going to be from here to here, whatever this wedge is to complete the circle. Well, I'm going to complete it. I know that this is 180 degrees, but 5, 6, so this is obviously 1/6. So 1/6 pi. Or sorry, 1 pi over 6, I should say, if I say it correctly. So 1 pi over 6. So that's the reference angle that would complete this. However, if I fold my taco over, folding it over, let's use a different color to represent that, then I want it in my, think about it in positive terms. So again, I'm dividing the upper half of my circle into 6. So that means theta prime would be right here. So if I thought about my theta prime in terms of positive radians instead of negative radians, then I'm going to go 1, 2, 3, 4, 5. So this is 5 pi over 6 pi. Those are my two reference angles. Okay, so I can think of it as 1/6 completing it. If I'm still going negative, or if I go positive and I'm looking at the symmetry folding my taco over, then it's going to be positive 5 over 6. Okay. And now I want to evaluate each of these angles. When it says evaluate, we can use our calculator, no big deal. We just have to pay attention to what mode we're in. Part A, we're in degree mode. Part B, we're in radian mode. I know we're in radian mode because I see the pi sign. So let's do part A. I'm in degree mode, so the very first thing I want to do is check that I am in degree mode. I am. Make sure you are. So I'm going to say tangent of negative 210 degrees. And I get a decimal, negative 0.58. For the cosecant, remember cosecant matches up with sine, okay? So we're going to say 1 over sine, but before we do that, we want to make sure we're in radian mode because we see the pi symbol, so pi means radians. So, and again, there's no button on your calculator for cosecant, so you have to remember cosecant matches up with the reciprocal of sine. So I'm going to type in 1 over sine of 11 pi divided by 4. And I get 1.414. I'm just going to call it 1.41. And that's it. And that's it for this video. Let me know if you have any questions. Typically, reference angles aren't used a lot because we have access to the calculator. However, back in the day when we didn't have calculators, reference angles were a big thing. So, as long as you can evaluate using your calculator, you're going to be good. Let me know if you got questions.